is sparkling with promise, leading India's aspiration to join the League of Developed Nations. Honorable Prime Minister Shri Narendra Modi envisioned a dream of making Indian trains catch up with the fastest in the world. Thus, Bullet Train project took off in collaboration with Japan, and then Japanese Prime Minister Shinzo Abe attended the groundbreaking ceremony in September 2017. The Bullet Train project is gathering speed under the supervision of National High Speed Rail Corporation, tasked with executing the first bullet train venture for 508 km long Mumbai-Ahmedabad High Speed Rail Corridor, popularly called NHSRCL Corridor. Zooming off at a speed of over 320 km per hour, Bullet Train requires a dedicated and compatible infrastructure of state-of-the-art rail line, bridges, tunnels, operational systems to name a few. Along with Japanese know-how, India is increasingly utilizing its indigenous technical and material capabilities to build the infrastructure under Make in India vision. Steel bridge is one of such examples. Unlike pre-stressed concrete bridges spanning 40 to 45 meters, which are suitable for most sections, including river bridges, long-span open-web girder, that is, steel structure of simply supported spans and continuous spans are most suitable for cross-highways, expressways, railways, DFCC lines. India has the expertise of fabricating steel bridges for heavy haul and semi-high-speed trains of RRTS and DFCCL, which runs between 100 and 160 km per hour. But never before in India, a steel bridge to support a Shinkansen bullet train galloping at a speed of 320 km per hour was fabricated. Japan, the partner of the project, had their doubts and suggested that the steel bridges should be fabricated in Japan. But assured of its capabilities, India did not relent. After visiting Indian steel bridge fabrication factories, Japanese engineers were satisfied with India's capability to manufacture steel truss bridge at India. Steel bridges are primarily fabricated in workshop. Once fabricated, they are transported to the site for installation. Through international competitive bidding process, India's leading infrastructure company Larsen & Toubro and Japan's IHI entered into the consortium and pitched their preparedness to fabricate the steel structures as per Japanese designs. L&T IHI engaged 6 numbers of workshops at different locations of India for fabrication of steel truss bridge. A total of 28 steel bridges are planned for NHSRCL corridor. Approximately 70,000 metric tons of specified steel is estimated to be used in its making. The length of these steel bridges varies from 60 meters simply supported to 130 plus 100 meter continuous span. The contractor procures steel from approved primary manufacturers. Each production batch of steel is tested by ultrasonic testing (UT) at the manufacturer's premises. Steel materials received at fabrication workshop are color-coded to identify its grade. Steel bridge contractor for NHSRCL corridor is entrusted with procurement, fabrication, check assembly, painting and transportation to various bridge sites of steel truss superstructures. A separate contractors are engaged for erection and launching of these special steel bridges over Indian Railway, DFCC tracks, highways and expressways, etc. The making of steel bridges undergoes high-tech and precise operations of cutting, drilling, welding and painting as per the design drawings prepared by Japanese engineers. Contractor is mandated to employ welders and supervisors certified by international welding experts. The welding process is also monitored by Japanese International Welding Experts (IWE) stationed at each workshop. Fabricated structures undergo check assembly process and then follows the sophisticated 5-layered painting of the steel structure. The painting technique adopted for the steel girders is first of its kind in India. It conforms to C5 painting system of Japan Road Association's handbook for corrosion protection of steel road bridges. TTHS bolt, that is, toe shear type high strength bolt, is used for joints of each member of the steel truss bridge. These bolts act through friction rather than bearing or shearing. The first of the steel bridges has been erected across National Highway at the city of Surat in Gujarat, that is GAD 1134. Once ready at the workshop at Hapur district near National Capital Delhi, which is almost 1200 kilometers away from location of bridge site. The steel structure, which consists of nearly 700 pieces and 673 metric tons, starts off its journey on heavy haul trailers to the site of installation. At GAD 1134, the steel bridge of 14 meter in height is assembled on the staging above 15 meter high piers. Thereafter, the launching nose of 38 meter length and 160 meter metric ton weight is assembled with the main bridge assembly. With massive care and expertise, the bridge assembly is pulled to its intent span through specially designed pulling arrangements under the complete traffic block on National Highway. Then bearings are fixed on the pedestal and the bridge is lowered on the bearings. With 2026 set as deadline to roll out the first bullet train, NHSRCL corridor will soon be bejeweled with dozens of steel bridges, all made in India.